good question. It's a bit of multiple parts in it. Suppose there is some structure here. It is fixed like this. Suppose it is a hook in your room and you will hang your clothes here. So this is that element practically. Now there are three forces acting because of some reasons. There are three forces F1, F2 and F3 acting here. Now what I want, determine the components of all the three forces F1, F2, F3. So let's do it. As a part of the answer, let's do the components of the force F1 first. As I said, everything is very simple, guys. No need to worry. Just follow my method. What I said, now I am dealing with the vector F1. So I marked it F1 here. Now, as I said, if nothing is mentioned, make this axis as X and this axis as Y. Clear. Next step, mark the starting point as A and the ending point as D. Clear. Then draw the lines parallelly in both the directions and make a rectangle. Clear. Now, as per the definition for the FE handbook formula, the theta x is angle made by this vector with the x line along x-axis with the line that is starting from this point A. So here this will be theta x, that is 35 degrees. Now what is theta y? As per definition, angle made by this vector with a line with an x-axis, sorry, with y-axis that is passing from the point A. So this will be theta y. So they did not give theta y. In the question, they have given only 35 degrees. So it is our duty. We know that both axes are 90 degrees. So the balance angle will be 90 minus 35, that is 55. So mark it here. You got both theta x and theta y. Now, what to do? Go to the handbook, go to the chapter statics, go to the formula, resolution of force. There you got Fx is equals to F cos theta x, Fy is equals to F cos theta y. Blindly submit it. Blindly. You will see where the error you can get. You will not get any error. As per the handbook, what is Fx? Fx is equals to F cos theta x. And Fy is equals to F cos theta y. I simply copy pasted from our handbook. Now, so what is F here? My F here is our concern vector F1. So place the F1 here instead of F to be very peculiar. And theta x is 35. So mark it here. And similarly for Fy, it is F into cos theta y. What is F we are considering? There are three vectors, but we are considering talking about the first vector. So mark it as F1 and then cos theta y is cos 55. So 600. So what is the magnitude of this vector here? 600. So 600 into cos 35 and 600 into cos 55 will be your Fx and Fy. Just feed the data. You will get Fx as this and Fy as this. Always remember, engineering, the FE exam is very easy, but only thing you need to be very clear about the units and sign conventions. So units is clear. The force is, since it is newtons, its corresponding components will also be in newtons. That is clear. Coming to the sign convention, this is our standard x and this is our standard y. So here the vector, the components will be here, here. When you break it, it looks like this. So they are along the positive x and positive y. That's why I have marked them here plus and plus. So remember this point, that is very simple. And if you want to use the only one theta, as I said, in some cases this will be easier, but in this case you can see this method is easier. Now, if you want to do by method 2, so I will zoom it down. I have marked the same figure here, the same axis, the same coordinates, the same theta. Now I have taken the cos triangle ABD. This is a triangle I have taken. Apply the properties of triangle that I have taken. So cos theta is equals to the adjacent vector here by the main vector F1. So Fx is equals to F1 cos 35. Again, you get the same answer. Now again, if you want the Fy component, consider triangle that has this Fy and mark it. So cos 55, instead of drawing the figure again, you can see it from here itself. So cos 55 is equals to adjacent vector, that is Fy by the hypotenuse of this triangle, that is F. So that is F1 here. So Fy is equals to F1. You get the answer as this, and it should be plus again because the components are acting along the considered positive x and positive y directions. So this is the case. Now, if you want to draw, if you want to mention this vector F1 in the vector form. You have to mention it in vector form. Sometimes if there is a complicated question, solving the question in terms of vector form is very simple. We'll see it further while finding the resultant of 2 to 3 vectors, 2 to 3 forces. So Fx is 491. You place it here before the I cap, and Fy is 344. Place it here before J cap or simply J, and mark the sign conventions. This is plus. Why this is plus? Since Fx is along the positive x-axis, and this is plus since Fy is along positive x-axis. The complete vector is in newtons. So this is how we form a vector form. Now, what is our next question? We want the components of all the three forces. F1 is over. Now we have F2 here. If you see the figure F2, it has a magnitude of 500 newtons, well and good. But here they did not give you an angle theta, but they have given the geometry. He is saying that this vector is going in such a way that it is vertically rising 3 units for every 4 units. This form of representation is known as the graphical or pictorial or geometrical form of representing a vector. So if it is mentioned in geometrical form, for the handbook, the one procedure, with the common sense, we can say that if it is 3 by 4, you mark it as an angle theta. By the definition of tan theta, you know that tan theta I have defined as, it is defined as opposite side by adjacent side. So tan theta is equals to 3 by 4. Then theta will be equal to tan inverse of 3 by 4. And we are using the tan inverse in the calculator. Just press shift plus tan, then feed the data, you will get the angle. After getting the angle, the method is same as handbook mentioned this. Now coming to the F2. So this is our question. So I marked this question here. I marked the standard axis X and Y, then placed the force and marked the geometry as 3 by 4. Now, this is if the geometry of the force is known case. So go to the handbook, take that formula and find out that the X is distance along X-axis as I said. So what is the X-axis here? Along this line. So distance along X-axis for this vector is 4 and for this vector Y is 3. And this is the hypotenuse. This is denoted by R. And R is equal to under root of x square plus y square. So R is now 5. Once you got x, y, and R, the formula is simple. F into x by R. So x is 4 by R is 5. So this is 400. Till here, the procedure is same. Procedure is simple. Now, the sign convention, you have to be very careful. What is x component in this direction? It is like this. So what it is against to the positive x direction. So its sign will be negative here. Remember this. That is the only thing to worry about. Coming to the Fy, the formula is similar, simple. Place it, you will get the answer 300 and the units is simple. Since the force here is in newtons, the component will also be in the same. If it is a kilonewtons, the component will be kilonewtons. And coming to the sign convention, its component will be in this direction if you break it. So when you are breaking, it is our basic common sense. When you split it, it will look like this. Now, this is along the positive y, so this is plus. Now, if you want to draw the vector form, minus 400, because it is minus here, I cap plus y component is this. So before j, place the y component, that is 300. So this is the vector form. Now, you did in the question, they have given this and they asked you components and you want to know whether the answer is correct or not. Then what you can do, if you want cross check if our components fx and fy are correct, then just do this formula. F is equals to under root of fx square plus fy square. For example, if you want to check whether these components are correct or not for F2, just simply do under root of minus 400 square plus 300 square. Make sure that minus will be inside the bracket, plus this, plus this. If you do that, you should get the answer as 500. So if it is 500, then it means that your components are correct. Next case, we'll go for the third part of the question. So here, what I do, if this is a question, I have already calculated F1 and F2. So I need not to worry about these forces. So for ease of understanding, I deleted all these forces and I have considered only force that I want. Okay. So this is kind of a bit tougher question, but if you solve this tougher question, whatever question you will get in exam for the components, it will be very easy for you. So I removed all other forces. The only force is this. Now, here also same case. He did not mention any angle here. So, but there are some distances here. So this is a part of geometry oriented formula. Again, they did not mention it directly. They just mention it indirectly. They are checking your caliber to next level. But you guys, you are attending our classes. Nothing will be difficult for you. What you do, since they have given distance till the point B, but not till point where the force is ending, you will consider the triangle, imaginary triangle. You just draw the line parallel to x-axis from here and draw the line parallel to y-axis from here to here. Got it? After this, the AC distance they did not give it directly for the triangle ACB. It is 0.4 minus 0.2. This is basic, by seeing visually, you can say that this is 0.4 minus 0.2. That's why you can see here AC is equals to 0.4 minus 0.2. Coming to BC, this is 0.3 plus 0.1. They just made the things a bit lengthier to check your concepts. So once you got AC and BC, the x direction, the x distance will be the one that is parallel to x-axis. Here in the question, you can notice that they have given the standard x and y directions. And so this will be x direction will be 0.2. Your question can be, sir, the vector is from here to here. No need to call me as sir, you can call me with name. So Mr. Vardhan, the vector is from here to here only, but you are taking as AC as from here to here. Will it be right? Yes, it will be right. It is like properties of similar triangles. If the angle whatever you calculate from here to here, it will be same as angle that you calculate from AC to AB. Either you consider this triangle or you consider smaller triangle where the vector ends, the angle you can notice that the angle is same. So you can take the x as 0.2, the entire length, and y as the entire length, that is 0.4. The rest of pressure is same, the R value is same, the formula is same, just simply substitute. But again, coming to the sign convention, if you break it into the components, it is along the positive, so plus. And coming to the Fy, if you break it into the components, it will be like this, so it will be negative since the positive y is in this direction. Our main intention, if you think it through the formula, the cos theta x, cos theta y, we just want the angle here, right? So if you want to find the angle, suppose you don't want to do this method using the geometric formula, but you want to do it using the angle formula, then what is the pressure? I will mark it. So what you just need to find the angle theta, right? If you find the theta, the answer is done. For finding the theta, we just pick up the whatever data is available with us. So I formed a triangle here, from here to here, I marked a line, and here to here, I marked a line, and then I closed this line from here to here, A to B. So then it formed a triangle theta, and then if once a triangle is formed, they have given 0.3. The distance from here to here, they have given it as 0.3. And from the point of application to this height, they have given it as 0.1 here. So what will be the BC now? It is nothing but 0.3 plus 0.1, that is 0.4. So this, and for this entire triangle, this will be 0.4. So this will be 0.4 and this will be 0.2. After that, the theta is simply, the basic funda. We have the data of this and this. That is, if this is my theta consideration, then we have the formula that tan theta is equals to opposite side. That is 0.4 by 1.2. This is 0.2. After doing inverse, then you will, after sending this theta tan there, then it will tan inverse of this. So you get the angle. So whether, suppose, to much clarify you, if they given height this thing only directly, and they have given this thing directly, but the angle will be same for both the cases, right? The angle, the triangle that is formed will be like this, and the angle is common. That's why even if you use the given data, even because they did not give the actual data, you can use them proportionately. Whatever considerations you have taken, it will be same for you. Got it? You do it as a homework. Example 10, this is a very simple question. Whatever you have applied there,